depends. I like problem solving math, but
All right. Do you like math in the classroom?
unfortunately, no, I don't like the math classroom environment. For me, math, I like to be able to problem solve and use what I know, but yet not just be given what you need to know and then just directly apply that. I want to indirectly apply it and use other things I know, like instead of doing repetitions and just repeating things.
Math is so tedious. When a teacher gives me math homework, I may appreciate the concept behind the math, but I'm not going to do it because it's doing the same things over and over and over. And you're basically being a calculator. You're doing something Microsoft Excel could do for you.
Imagine that you had to take an art class in which you were taught only how to paint a fence or a wall, but were never shown the paintings of the great masters. Would that make you an art lover? Years later, you will talk to your friends and say, "Oh my gosh, I hated art at school. I was so bad at it." What you would really be saying is, "I was bad at painting the fence." And likewise with mathematics. People often say, "Oh, I was so bad at math. I hate math." But what they are really saying is, "I was bad at painting the fence."
What I really hate when I'm in math class is when they give me a sheet of 30 of the same question except with different numbers, and I have to do the same thing 30 times. It's just really tedious. I hate it, and it's the reason I don't do my math homework, and that's the reason I got like 50% on my math tests.
Okay.
Yeah, I definitely think there's room for. Actually, it would be great if there was a shift of focus from repetition and practice to an understanding, a deeper understanding of the formulas and the way they're derived, because that's the interesting part of math. I hate math, but I really appreciate that part of math. If you let students figure out math further on their own, with the formulas and everything, except doing the same thing over and over again, more people would appreciate math. But you're kind of taking out the practice makes perfect part of it, so I'm not necessarily sure if that's an improvement. Considering I don't want to go to math class, considering I'm skipping math class right now to do this interview, no, not really.
In 5th grade, my math class studied number patterns. We looked at sequences whose increments were sequences, and in my own exploration, I found Pascal's triangle. While young students like me had not yet practiced math to proficiency, all of us were born curious about the world around us and explored in our own way. Unfortunately, many of us eventually shy away from classroom math in sight of loads of seemingly pointless work. If it is our goal to cultivate our natural curiosity, as Gauss once said, truth of this kind should be drawn from notion rather than from notations. Math is the beautiful language of the fundamental nature of the universe, but its learning demands hard work with painstaking practice. Is it possible that students learn to both exercise and appreciate mathematics? To help me answer this question, I interviewed experienced UTS math and computer science teacher, Mr. Sergey Yanin, for some insight on the matter.
How do you call it? Practice makes perfect. Right. The question is, what's based on? Most important thing is to understand that we are not solving real problems. We are playing with models, the small ones, the simple ones. It really depends how it's introduced. From my point of view, everything should start with stating a problem. For example, from my point of view, it's wrong to say, okay guys, today we'll start learning trigonometry. Sine is this, cosine is this, tangent of this, and we go. That is wrong, because at this moment you lose the reason why we do that. As a school subject, I really like to make a link between something simple and what it leads to. Like for example, right now, let's say in calculus, you are learning about what? Derivatives, maybe something about integrals. Right. But at this level, we are that close to something, to so-called real models of physics. And not only free fall, but fall in the air or motion on the water. That close, and that's what makes it really interesting. And that's probably would be In computer science, it would be this. In computer science, we are not actually even close to the difficult problems of with database or artificial intelligence. We are very close to creating a little game, childish one, but something you would feel how it works.
Right, like Tetris.
That's right. Given available tools to solve difficult problems.
Right.
For example, after being explained a certain type of problems, students, let's say, are given 5 questions. If they come back with a solution of 2, it's considered a good result. We as teachers want students to succeed. The question is, what is success? Passing a test, I can gladly give you like 20 repetitive tasks. You do all of them, they give you 100% at the end of the story.
Right.
My life is easy because the entire classroom will pass. Your life is boring.
I say that one of the problems is that there's this fear of failure both by the system and by the students at every step of the way, which holds the system back because actual learning requires failure as part of the process.
Again, it's not a requirement, it's not intentional, but in a good sense, you cannot avoid it.
Right.
You should be ready to fail from time to time.
Of course.
As I was saying to the students, and it's really a shock to, let's say, at once, when I say, our goal is to bring well-balanced people, well-balanced, those who know how to deal with success and failure.